When emergency first responders were overwhelmed by Los Angeles County's most destructive fire yet, a band of surfers, along with their neighbors and friends, stepped up to defend their home turf in Malibu. Their devotion to home drove them to show up for their community during the fire and for years afterward. And now, a model they call the Community Brigade program could change everything, leading to more lives and more homes saved during the increasing wildfires across not just California, but the world. Join reporter Adriana Cargill from KCRW, NPR's All Things Considered, Crooked Media, and more, as she investigates a wildfire story that is not depressing, but is, in fact, a clear hope for the future. Listen now to Sandcastles, an award-winning podcast about home, how we create it, and why we fight so hard for it. Hey, everybody. It's Quinn, and welcome back to our Good News series. Thank God. Today's episode is a replay of one of our most popular, number 51. What the hell is CRISPR? Our guest was Professor C. Brandon Ogbunu. Brandon's an assistant professor at Brown University and one of the coolest dudes we have ever talked to. Brandon's perspective on data and disease and how evolution and ecology influence them really just blew our minds and is just truly a fantastic, inspiring, fascinating conversation. Of course, being where we are right now, Brandon's specific scientific expertise and his perspective as a Black man could not be more timely than it is. So please enjoy this awesome conversation. What the hell is CRISPR with Professor Brandon Ogbunu? Thank you. Welcome to Important Not Important. My name is Quinn Emmett.
And I'm Brian Colbert Kennedy.
And I forgot to bring Teddy to work today.
That's true. I forgive you.
Yep.
This is the podcast where we dive into a specific topic or question affecting everyone on the planet right now or in the next 10 years.
Or so.
If it can kill us or turn us into CRISPR robots, we're into it. Our guests are scientists, doctors, engineers, politicians, astronauts. We had a reverend, and we work together towards action steps that our listeners can take with their voice, their vote, and their dollar.
And Brian, this week's episode is, hey, Brian, are we thinking about CRISPR all wrong? Also, what the hell is CRISPR?
This week's guest is Brandon Ogbunu. He's an assistant professor in the Department of Ecology and Evolutionary Biology at Brown University. He's an evolutionary systems biologist and uses experimental evolution, mathematical modeling, and computational biology to better understand the underlying causes and consequences of disease across scales, from the biophysics of proteins involved in drug resistance to the social determinants underlying disease. Holy shit. In doing so, he aims to develop theories that enrich our understanding of the evolutionary and ecological underpinnings of disease while contributing to practical solutions for clinical medicine and public health.
I couldn't be happier that I made you read that entire thing.
I fucked up one word.
More or less, it's just preposterous.
It's insane the amount of...
Would you say, and I know we've talked about this before, and it's weird and it's creepy how much the answer is yes, that description more or less matches up with your day-to-day responsibilities here at Important Not Important.
Exact same.
Pretty like 80%, right? You would say that you guys do the same stuff for 80% of the day?
Good God.
Yeah. Super smart dude.
I almost want to say that you're making some of that up, but you're not. That's his description.
Where would I get those words?
I have no idea. I don't know how I said those words.
Yeah, not even close. Love talking to this guy.
He's awesome.
Want to go take one of his classes immediately. But I did college, and it was fine, and I barely escaped. So I'm not going to do it again, but I'll take it.
I will just say this: he was just the perfect. Like, this is who I want all my teachers to be.
Oh, I know.
The perfect man to be an educator. So great.
Would that have changed things for you?
Everything. Probably nothing.
Nah, probably not. All right, awesome. Let's go talk to Brandon.
Cool.
Our guest today is Professor Brandon Ogbunu, and I should mention his Twitter handle is, unless I'm mangling this and it's the wrong person, is Big Data Kane.
You got it.
And
good.
I cannot tell you, as a big data loving former asthmatic who cherishes tight lyrics in the golden age of rap, how many boxes that checks for me. So I'm looking forward to it. Anyways, we are going to ask together, are we thinking about CRISPR all wrong? And we're going to also tell you what CRISPR is, because I have a feeling most people don't have any idea what the hell we're talking about. But that's the goal today. Brandon, welcome.
Appreciate it. Thank you for having me.
sure, man.
We are very happy to have you. Quickly, just tell our listeners who you are and what you do.
Great. So, like you heard a little bit, I'm a professor in the Department of Ecology and Evolutionary Biology at Brown. And I'm a computational biologist that's interested in what I call diseases across scales. That means everything from the very molecular level, like how the genes and proteins interact in certain disease, to the societal level, like how the kind of people and cities and the climate and all that influence the way diseases spread.
Fascinating.
Damn.
That feels pretty timely with everything that's going on with the fight that the Congo is still dealing with Ebola and things like that. And all the measles outbreaks all over the world because people refuse to vaccinate their fucking children.
Mm-hmm.
Very interesting.
Oh, man. Don't even get me started.
That might be a different conversation. Awesome.
Awesome. So it's been, I guess, it's been a little bit since we recorded an episode. As a reminder to everyone, our goal with this whole thing is to provide some quick context for the question that we are asking, and then dig into some action-oriented questions that get to the heart of why we should give a shit about it and what everyone out there can do about it. So if that sounds good, Brandon, let's do that.
Let's make it happen.
Rock and roll. So, Brandon, we like to start with one important question, sort of set the tone of things. So instead of saying, tell us your whole life story, we like to ask, Brandon, why are you vital to the survival of the species?
Well, I confess I cheated, and I've heard a few people answer that question. I think, and most people, they do it thoughtfully and modestly, and I'm not going to be modest.
Yeah, get it.
I think. Nah, I'm just playing. I think what I'll say is, I like the stuff that I do, and I think I work on important issues. What I'll say is less me personally, and just more people like me. I think who are unafraid of kind of walking into new disciplines and fields and being the dummy in the room and asking difficult questions. That's really, what defines my career. So I think a question like this, and you ask me 2-3 years from now, I'll have a different answer. Like I'll be working on different problems and different questions. And I think, my interest in gene editing, for example, is an example of that. So I think that's what I'd say, kind of being courageous about entering new fields, asking difficult questions and moving on that.
I love that, man.
Yeah,
I think
being
that's
a
important.
leader.
Yeah. We need more of those for sure. All right, awesome. So we're going to set up some context for today. So I got some notes here to get everybody on the same page. Brian can ask some questions. Brandon, you can tell me all the specific places where I'm wrong.
Yeah, you'll probably be correct, Quinn.
And that'll be great. So what the hell is CRISPR? Stolen from Wired magazine, one of my favorites. CRISPR is a quote-unquote revolutionary new class of molecular tools that scientists can use to precisely target and cut any kind of genetic material. It's scissors for DNA.
There you go. Thank you for that.
Yeah, you're welcome. How new is it? It's pretty fucking new. Two hardworking genius ladies, Jennifer, I'm going to mangle this, Doudna,
I think that's
Brandon,
right.
do you know which one? And Emmanuel Charpentier published and patented the process in just 2012, which is not a long time ago.
No.
And shit has kind of gone off the rails since then, in a good and maybe not so great way. So what does it do? CRISPR systems are the fastest and easiest and cheapest method scientists have ever had to manipulate the code of life in any organism on Earth, humans included. It is scissors. It truly is scissors for the code of life, right? It's like search and replace on, hopefully you're not using Microsoft Word, but whatever you're doing, right? Word. So it's exciting, right? It's new. It's also terrifying. And it's obviously more complicated than it sounds. As usual with science, which is great, we're finding out a lot of what we don't know. But what we think we can do with CRISPR, let's see, everything, the dreams of biohackers everywhere, right? We could theoretically eliminate disease at the germline forever in humans or mosquitoes. We can make plants and food more efficient and productive. We could bring back an extinct species, right? So the better question is, what can we not do with it? We're finding out, again, what we don't know. And again, that's science, and that's important, that there's stumbling blocks. And finding out how the body interacts with itself. So we found out most people could basically be immune to CRISPR or not, because our DNA, our species DNA specifically, has spent a hell of a lot of time developing ways to defeat intruders or changes to the source code, which is what keeps you alive. You're welcome. So I think what we're going to get in today is we haven't even made up the rules for using this stuff yet. And if you've watched anything with, for instance, the U.S. Congress in the past year trying to just figure out what the fuck
Facebook even is. These old white people don't know what that is. So getting them to regulate CRISPR is an entirely different issue. So because it's at least in some ways really simple and there's not a ton of rules, there's been a lot of chatter about how to make those rules, and a lot of enterprising folks and future supervillains don't really care as much, and they're just trying to get out there and doing the damn thing. And obviously there's been some news about that recently.
Yeah.
That could really change the world one way or another. So what I want to get into is, Brandon, maybe you can offer a more concise description or an example, a specific example of how it could potentially use what we know about. And then we'll get it to our bigger question of, are we thinking about CRISPR all wrong? Are we asking the right questions at the right time?
Yeah, I think your summary was correct. Even at the detailed level, you got most of it right. I think
shocking.
I think you go back to the 2012 discovery and the other discoveries after that about how we were able to use it to do these very cool and interesting things. But I think it started with a discovery, right? A very basic science discovery in bacteria, and I think that's what makes CRISPR such an exciting thing. And it has this weird acronym. It's clustered, regularly interspaced, short palindromic repeats. Who cares? Whatever. But the point is, it's basically a primitive, ancient immune system for bacteria against viruses, right? So this is something that kind of exists in nature already, right? That we were able to kind of wield for this practical purpose, right? And I think that's kind of one of the neat things about it is, evolution kind of optimized this thing for a different purpose, and we just kind of co-opted it, rather than some of the other, genetic modification technologies that we've tried over the last, 20 years or so, which were really a lot more, artificial. This one is very, very particular and precise because it kind of, had a very particular and precise function in a highly successful organism like bacteria.
So what you're saying is it was less typical with humanity. This was less invented and more discovered. It was something that already existed. And like you said, we're learning how to wield it. Is that correct?
Yeah, I mean, I'm not a patent attorney, right? So they wouldn't say that, But
and that
the people
that's been a big part of it,
debate.
Right?
That's been a debate. That's been the debate. But I think, what I would say is, I think the genius of it was, in fact, that it was a co-option of something that nature used very intelligently already, right? So that doesn't make it less innovative. That makes it more innovative. So
sure.
But I think that's kind of why it's been so effective, and why the minute it was applied the way it was applied initially, we've been able to kind of use it for all these different reasons.
I love that. So for everybody out there, and I guess Brian, I asked Brandon, what's a question about CRISPR that keeps you up at night? And Brandon, maybe you can tell the people what you told me, and then we'll go from there.
Well, many things about CRISPR and, genetic modification writ large keep me up at night. I think part of this, has to do with my own ontogeny as a scientist and a thinker. And I think, I think we're all influenced by different ideas that were around. And, whatever your major was, I'm sure there was a big controversy in your field. And I think with me, I'm a child of, I'm a child of the AIDS era, and I'm a child of the first genomic modification era, which was gene therapy. And I think gene therapy was a big deal in the end of the 20th and the century, in the early 2000s, or more in the end of the 20th century, in the 1990s, late 1990s. And that was supposed to transform everything. And all of the stuff I hear, the confidence, right, about how we were able to eradicate genetic disease forever, and people were saying the exact same things. And I wasn't a kid. I was, I was late in college or applying to graduate school around that time. And I saw that movement come and essentially overnight disappear because they were things that people were not considering at the time. So what happened was, in 1999, there was a clinical trial where a patient in a clinical trial was killed in a gene therapy, for a disease that the individual had. And I think overnight, there was like, whoa, wait a minute. And I think in hindsight, you look at it, and I think the, ethical, review of that clinical trial were like, yeah, there's a lot of things that went wrong, but there were a lot of more than that particular clinical trial. You look at the whole field just kind of had blinders, on, and didn't really have tunnel vision, and didn't really see the massive kind of potential scientific issues, right, and the ethical issues. And I think there are analogies between that era and this era. And I think we're inclined to, we might make some of the same mistakes, I think.
Have we learned anything?
Yeah. Does it feel like some of those mistakes won't be made this time?
Well, so a couple things. So I'm not apocalyptic about it, and I think I like I like my sci-fi apocalypse stuff as much as anybody.
Sure.
We can even talk about that later if you want. But because I think those things are actually useful for thinking about a lot of these issues. So let me say something good, the good stuff first, and that is that the science is way better. Okay,
right.
I think the gene therapy technology where we deliver genes via a virus. I mean, it was just messy for a lot of reasons. And I think that was the problem, is you couldn't really control exactly where you put a mutation or suite of mutations in. And I think there was a lot of or you could, but not as precisely as you can with CRISPR. So the CRISPR is very, very good technology.
I try to do this sometimes because I'm a nerd and I read about this shit, and obviously you work on it, but could you take a step? You mentioned how precise CRISPR is. Could you just give a specific example of again, dumbed down for everyone here, exactly what you mean by how precise it is and what we can do with it?
I mean, there are experiments where, you have, the millions and millions and millions of nucleotides, right, in a genome of an organism. I mean, we can exchange, single, nucleotides or short kind of sections of a gene. We can delete very, very short sections of a gene of like several nucleotides. There's that much resolution with this technology. Crazy. So it is very, very, very precise in terms of what it can do at the genotypic level. It really is a remarkable piece of technology.
Wow. So it's understandable why has been so much excitement and the freight train is moving so fucking fast on this thing.
Well, no question. And I think there's a lot of reason to be excited about it. And I think that's kind of part of the concern, right? I mean, I think it can do a lot of wonderful things for a lot of people in the world. And I know, I don't know where you stand on the GM crop issue. And I think that's part of the problem is that, right, the issues with genetic modification are different depending on the organism you're talking about, right?
For sure.
So if we can kind of make, if we can make a better, we can make a crop that can survive, right, rough conditions better, you can feed a lot of people, right? You can do a lot of good in this world. Now, again, ethics of that and the economics of that and who can patent this and that, that's a different conversation. But at face value, right, growing things is not easy in every part of the world, right? And that is actually a bottleneck in some places to people being able to, to eat and get, nutrients.
And it's getting harder in a lot of, I mean, you look at what's happening in India. I mean, farmers are literally killing themselves by the thousands because they can't grow food anymore.
Exactly.
With pesticide.
Exactly.
Right. And you have so you got a bunch of white people in Santa Monica who say, I don't eat GMO foods. And farmers in India are going, please find some way for us to grow food again.
Exactly. So on that end, there's a lot of promise. It's funny. I don't know if y'all are beer drinkers, but like I just, I read a manuscript where, they're kind of like optimizing the yeast, right, to be able to make better pilsners with CRISPR.
Sure. Everybody
so, I mean, on all levels, this has the potential to do a lot of good. So I think, that's exciting. I think on the problematic side, right, there are a lot of concerns, even within GM crops. So let's put aside the economic stuff about who owns what and patenting and all that and the corporate interests and all that. At a basic level, right, there's the scientific issue of, right, this is a science question. This is before we gotten into right and wrong. And, there's a science issue of how do you know that a given mutation or suite of mutations that you put into a genome of an organism that, right, confers phenotype A in this organism is going to do the same exact thing in all other organisms of its kind, right? So I might have isolated a mutation that helps a tomato ripe faster, right? But if I take that same mutation and I put it in a, let's just call it a cousin tomato, a related tomato that's not exactly the same, how do I know that that's going to do the exact same thing, right? The answer is we don't. They are, and I think that's a fundamental question of basic science, evolutionary genetics that is very, very relevant. We call this, we call these things with mutations off-target effects. You can target this one thing here, but it could have these other effects throughout the organism and genome, right? Because it's hard to know exactly how everything fits together, right? The genome is not just this linear stretch of information. These things are interacting with each other, right? So you mutate this one thing, thinking you're going to get this one phenotype, and due to this is a process in evolution we call epistasis, and who cares? But basically, what that is it's the interaction between mutations at one site in a genome and kind of mutations at other sites in the genome. And really, this can make it difficult for us to predict very, very carefully how, if I know that this mutation is really going to make the beer better. It might, and it might do it 70% of the time. The issue is in beer, who cares, right? You get a really good beer, I get a lousy beer. Who gives a crap, right? But when you're talking about engineering Homo sapiens babies,
slightly bigger deal.
It's a slightly bigger deal,
right? All of a sudden, you got the fucking X-Men, which, like, for better or worse, is complicated. And you're right. I mean, we haven't even gotten to the ethics part of that, which is like all of the handicap folks are going, I understand why you think it's cool to get rid of my handicap, but also I live a whole life and there's a culture based around this. And why would we want to get rid of it? Anyways, but you talk about the science. I mean, it comes back to, like, despite all the technology and all the computing power and the machine learning we have and the ability to pick up on patterns and all the genomes we've scanned and things like that, even though they're mostly white people, we look at something like the microbiome, which it feels like every month we're like, wow, we didn't know that, or wow, we didn't know that. And like you said, it would be great if we asked these questions or took some time to think about questions and applied them to a fucking tomato before we even consider doing this with humans. But unfortunately, that's not the way it's gone, has it?
No. And I think we're finding now, right, like with any big discovery, there's, I think the news or the publication record self-selects for the good stories, right, for the successful stories. And I think, and understandably so, right? And I think there was a lot of excitement because it's really done some really, really cool things. But now we're starting to see, we're getting, I don't know. There are examples now where, CRISPR is causing, double-stranded breaks. The particulars of that don't matter, but it can cause kind of like mutations in other parts of the genome. It can cause these kind of unforeseen effects in other parts of the genome, which, and that is legitimately frightening. And I think this is actually at one point got the market, when the market responds, right, people are like, that's how you know it's serious. Even though the CRISPR market was like, wait a minute, what's going on with this? So there are these examples that have already happened. And these are actually starting to come out more and more now. So say, for example, I CRISPR, I want to add this run of this set of nucleotides into one gene. I can cause deletions, right, in another gene, like somewhere else in the genome. And that's bad. That's really, really bad.
That feels like an understatement. Yeah.
That's right. So yeah.
That's crazy. And we just don't know and again, all the credit in the world to the people who are working on this and the people who have spent, like you said, the past 20 years working on genomics and things like that and the Human Genome Project and all that. But again, we just haven't made that much progress on it to be able to say, like, oh, cool, now we can cut shit out and replace it with whatever we want. We have no idea how that's going to affect. In most cases, we have no idea how that's going to affect other parts of the genome, which is so complicated.
It's interesting because the problems with genetic modification, I think, the good news is that a common problem, right, I mentioned earlier, of what does a given kind of mutation do in an organism? That problem is it's common throughout the genomic world. It's not just about genetic modification. So, for example, the question of the fears of genetic discrimination, right, where right, you have a mutation that gives you a higher probability of acquiring schizophrenia at some point. The fears that will kind of lead, right, that you'll have a society where that's going to happen, and the fears of genetic privacy. These are all based on that same problem. We really don't know all that well how to tell for sure how a given mutation or run of mutations in a gene is going to do blank. There are very, very few examples in the history of medicine or biology where we are really, really sure that this mutation does something. So the classical ones we know Tay-Sachs, we know sickle cell anemia, we know these right. There's some that are like, you get these mutations you're going to have X, right, problem. Usually it's disease things that we've characterized that way. But for the vast majority, vast of majority of phenotypes that we care about, it isn't that simple. It's kind of like most kind of traits that we care about, even, morphological ones like height, are dozens of different mutations and hundreds of different genes that are interacting in all these kind of messy ways. And so we're dealing with that problem now in the basic science of understanding of who we are. Mm-hmm. You take that problem and the genome modification problem kind of has all of those issues in it, because we're just not very, very good at being able to disentangle what individual things are doing within a gene.
And to me, again, it's so hard not to just barrel right into the ethics questions of this. And obviously, we're definitely going to get to Gattaca at some point. But it does seem like, again, as quickly as this train is moving scientifically, and as much as there's obviously been some slightly terrifying recent news about this, about the science actually being executed, it does seem like, though we have learned some lessons in what we should do, it does seem like ethicists are actually getting the chance to chime in on this, as opposed to, for instance, anything coming out of Silicon Valley these days, where the mantra of move fast and break things has truly fucking broken everything. So maybe not enough or as much as we'd hope, but do you feel like there are, so again, let's stick with the science for just another minute. Are there science questions we have answered? Where have we made progress since 2012?
Well, I mean, so on the science front, I think this, I'm not pessimistic necessarily about this. I mean, in the sense of, or rather, I don't know about my future outlook, but I'll think about my current outlook. I feel like the science is fantastic, in a lot of ways. And I think it has a chance to do a lot of really good and cool things. I mean, even even just in terms of laboratory tests, I think the science is doing quite well. So I think since 2012, we have kind of new ways to deliver CRISPR-Cas. We can do it better. We can do it in more organisms. So I think, we are developing better and better technology around CRISPR. So I'm pretty confident about that. I think, just generally speaking, like getting into the ethics, and, we can talk about that. Mm-hmm. Yeah, I mean, I think we are, trying to stay ahead of the science in a way that we once did not, right? So, yeah, I mean, there have been a lot of good conversations. I think, the genetic privacy conversations, which at one point the technology got way out ahead of the law. I think the law is kind of caught up in them many ways, and I think, not to say this is not going to be a problem moving forward, but I think the conversations are being had publicly in a way that, for what it's worth, I'm reasonably satisfied with.
I mean, here's the thing, though. It's like I'm glad we are. I'm glad we've clearly learned some lessons, because it's the fucking Spider-Man quote, right? Which you can attribute to anything. Mm-hmm. With great power comes great responsibility, and we as a species don't fucking do well with that very often, right? From I mean, nukes backwards and forwards, but you look at what has happened. For instance, I mean, look, the inevitable. It seems like the inevitable outcome is there's going to, and it's the same way with the all these genome projects, is we're going to attempt to use them for good. And I'm not trying to be apocalyptic about this either at all. I'm just trying to I'm trying to illustrate the broad spectrum of where people should ask questions. And it just, I look at what is I guess to be specific, I look at what has happened with data in the past 18 months, and you go, oh, if you apply this to that, then it's actually Gattaca. Maybe at best, right? And so, again, yeah, I'm curious, like, where are we having the success on the ethical fronts?
So I think it's fascinating the way you kind of articulated that, and I'm a huge Spider-Man fan, so
yes,
that resonates. But I think here's the issue, right? I think with all things like CRISPR, all kind of big breakthroughs, be they technological, be they the algorithmization of everything, like you're talking about. In the data space, I think there's kind of like three things about people, right, that are hard to distinguish, and all three of them kind of when it together cause problems. People want to help people, right? Like, and not everybody wants to help people, but people often want to help people. There are a lot of people who want to do good in this world, and I think there are people who wielded the original right, gene therapy stuff that I told you, right, ended up not working, who really, really wanted to help people.
Mm-hmm.
I think people want to be famous and people want to be rich.
Mm-hmm.
And I think those three things, when they get right, people aren't good at being able to kind of distinguish those things. So I think people who are wielding these technologies in blind. So, for example, the recent case in China, right, of the presumptively, we still don't know for sure,
Right.
But the first CRISPR baby, which has a deletion in a gene that confers resistance to HIV. If you read the comments from the scientists, he might be full of shit, but he sounds like he did something meaningful for someone.
Right.
Right? Like, so basically the parent, I think the father, but one of the parents is HIV positive.
Mm-hmm.
Okay. And there's a lot of discrimination, right, as there is in stigma against the HIV positive community there, or as individuals from. So the notion is that, I can have this child that will never have to face that stigma by virtue of them having essentially no chance, right, of getting HIV, which is just kind of weird for a bunch of reasons, but there's a lot of ways to not get HIV, but HIV is not like a cold. You don't just catch a cold, whatever. The point is, there is a appeal to, right, emotion there, and I think the scientists very well might think that he did something right.
And history's
right?
littered with those people, right?
That's right. That's right.
Who maybe who are doing it from a sense of integrity, right? And a sense of being progressive and thinking like, oh my God, look what he can do. Why would we wait to do this to help these people? Right.
That's right.
But then again, I mentioned before, there's been these discussions of you talk to again the handicap world, which is huge and wide and varied, and these people are incredible. And they go, let's talk about blindness, for example. There's a culture and there's a community there, and these people are going. So wait, if you cut out blindness, or all the different degrees of blindness and variations on it, you lose that culture too. And someone who just barrels ahead and says, "Oh, look, I've cured blindness in a couple girls from Iowa or whatever," all of a sudden you go, "Well, it's just so complicated." And that's the fun and importance of ethics, right? But I also think, and this might not be your ballgame, and maybe it is. Everyone rips on the Star Wars prequels, right? Right. And there's this great, the whole thing is like a Jedi is not supposed to fall in love and all this shit. And there's this great quote by Rian Johnson, the guy who made the last one, The Last Jedi, where before, like, it was right when he got hired to make it. And everybody rips on the prequels. And he gave this quote about him saying, "Devil's advocate, the prequels are a 7-hour-long kids movie about how fear of loss turns good people into fascists." And it's really interesting because it's, Anakin, who turned into Darth Vader, did some really fucked up shit in both that third movie and then obviously going forward. But to him, I mean, maybe killing a bunch of kids maybe wasn't, a little consumed by the dark side. But again, people do things out of what they think is a good intention or a protective intention. And, what if a scientist who figures out how to cure blindness has a 2-year-old blind daughter, or what's the further extreme of that? And it's really complicated. And I'm glad we're having these discussions, but
yeah, that Chinese scientist doesn't, from all I've read, it doesn't seem to have any ill intention at all. He was just probably super excited about the fact that he could do it, and unfortunately did it without enough, research.
Right.
As opposed to asking, how do we keep this from causing some terribly awful shit, possibly? Are there innovative new ways to confront the ethical implications and science and the combination of the two?
Yep. So, I think, to the Chinese scientists, in particular, who did it, and I think it's a tremendous kind of biological feat, right? I think, but I think there's some actual scientific problems with what was done, and not even ethical. Like, so we think that the embryos are what we call mosaic, which means the different cells might have different kind of genetic information in them, which is not good. So there's even some scientific. That's one of the reasons why it's unethical, because even what was carried out scientifically just looks like it might have been in some ways sloppy, because that's kind of where the technology is.
Sure. But that goes back to just basic fertility. I mean,
that's right.
If you're doing in vitro fertilization, you don't put in mosaics. They're graded in two different ways, and you put those in. It's just like you said, it's just sloppy.
That's right. No, it's very, very sloppy. To the point, now that we're into the ethical things, and, it's part of the conversation, the point you made about the handicapped community in particular was a very, very profound one, because this is one of the areas and one of the reasons that this technology, right, could cause us serious problems. We need to stop and think about why we want to modify certain things about who we are, right?
Mm-hmm.
So, damn it, you have a right to like a Pilsner that's hoppy or whatever. There's no consequences there, right? But again, to say that something needs to be eliminated from the species is to cast a very particular type of judgment about that thing, right?
100%.
So like sickle cell anemia sucks. It's awful, right? So is Tay-Sachs. There's certain things that we can kind of all mostly
all
at
agree
least
on, right.
agree, right? To get rid of, right? But speaking of Gattaca, right? There's I don't know if it's an alternative ending or an alternative trailer. I think it's an alternative trailer. You should watch it sometimes. It's a very beautiful, beautiful trailer, and I've showed it in class. And what it says is, it shows a picture of Albert Einstein, and then it says dyslexia. And it shows a picture of like Virginia Woolf, and then it says something like manic depression or something. I forget who it was. Maybe it's Emily Dickinson. I forget who it is. But my point is, a famous writer. And then it shows all of these kind of historically, famous people, and it shows the afflictions that they had.
Right.
Now, we don't know for sure whether or not, right, that the source of that thing was genetic in that individual. But it's making the point that, right, it very well might be true, right, that certain things that we associate with a problem are only problems because we've made them a problem, right?
Sure.
I think a very, very personal example, right, and something that is very, very personal and relevant to my experience as a scientist and a person in America is, if you told me a mutation in Homo sapiens that would be profoundly influenced with lifespan and where you lived and how you lived, really, even today, but by law until, right, half a century ago, it would be for black skin, right? Right? And so in a situation, right, where you're like, oh, I want to kind of engineer a child who has a better set of chances in life, well, right, it's very, very obvious, right, that the decision in that situation would be to engineer a child without black or the phenotypic features of being a black person in America, right?
Sure.
But as we've observed, that had that phenotype, that's entirely a human decision that we've made to treat certain people certain ways. And so if we're not careful and thoughtful about the things that we want to change about ourselves, and because some of these things are entirely about kind of the way society is engineered. And I think this is the real problem with CRISPR, right? It's not like taking Tylenol, right? So when you take Tylenol because you have you banged your knee or something like that. You take Tylenol, the pain goes away, and then the Tylenol vanishes from the bloodstream, and right, it never affects you again. When you change the genome of something, you have changed future generations. Right. It's not, right? And so you've kind of taken away the ability of human beings to be able to decide whether or not this thing is actually, good or bad by virtue of the fact that society changes.
Right.
So, yeah.
And I mean, let's talk about, again, let's say you have the quote unquote opportunity to genetically modify an embryo so that it comes out less black or it doesn't deal with those superficial things that we have used as instruments to just wreck the African American race for 400 years, right? So that's you. Part of you goes, I could see why that's an advantage, and then part of you goes, but what about the things that we lose when that child doesn't get to have that experience, or what could they not contribute to culture? And then the third question is, all we do as humans is look for the easy fix, and maybe that's not the fix that this situation needs. maybe we could take a step back and go, are there other ways to address this problem so that this
Right.
child doesn't have to experience this, but also gets to keep and inherit this incredible culture that he is going to come into, or he or she is going to come into? Does it have to be snipping out this part of his genome and his skin color?
We never get to the root of it's never the root of the problem that we solve. It's always, how do we just fix it now?
Right. How do we just make them look different? Look, everything is all better and they don't have to do that. It's like, no,
Right.
well, why don't we just treat them better? How about we fucking
Yeah.
start with that? And you go, it applies to, let's look at autism. I mean, look, I'm not afraid to say, two of my kids are test tube babies and they had to be. And so that's why I can speak about fertility and mosaics and all that shit all day long. I basically got like a PhD in that shit. And, you look at it and you go, oh, these are the genomic things that came up. And we had hundreds of bad embryos, quote unquote, bad ones that came up for different things, or it didn't have an answer, which is almost just as bad because you find out later. And one of the things, obviously, you look for autism, but then you look at some of the ways progressive and innovative people have looked and go, wait a minute, this autistic person might not fit into society in this way, but look at this specific almost superpower they have in other ways that can contribute to my cause or my mission or my company, whatever it might be. And again, you have to ask the question of like, what do we lose when we do that?
I mean, I couldn't have said it better. I mean, so on the artistic side, and in particular, I mean, that's a fascinating phenotype that is a great example of how conversations about, right, so the neurodiversity movement is kind of one of the things where, and that's transforming the way schools are structured and the way we're educating people, and that brains are different and minds are different. And just because, right, somebody's a little bit kind of different, whatever the heck that even means, right, doesn't mean that they're suffering from an affliction. And I think the autism community has done a really nice job of that. I think in the context of things like race, and in terms of like things that part of the problem in terms of us thinking there's a quick fix goes back to why you asked me why I'm vital to the species or whatever you asked me, right? I think it's because a lot of the people who are doing the CRISPR don't think about society, and they don't read that literature, and they're not thinking carefully about these things. And I think, right, so like, interdisciplinarity or, there's a lot of phrases for that now are essential. So take me, for example, like, I mean, the reason that I'm a scientist now, unquestionably, even if you're talking about biological inheritance, is because of my mother, right? My mother would have been a scientist if she was born with more opportunities. No question about it. No issue, right? The reason that she was not is she experienced the tail end of Jim Crow, right? Sure. So it's one of those things where, because I understand the experience of how a phenotype, right, that it can be arbitrarily, right, I now enter these conversations like, you know what, maybe y'all need to think about why you want to edit that thing, right? Because I know somebody who was genetically equipped. I mean, she was a math teacher, which was about as high as you could go for that demographic.
Right. I mean, black people have been experiencing Gattaca for 400 fucking years.
Right. Exactly. And so you gotta be, and I think Gattaca, it's funny, man. I was on Twitter the other day, and it's been over 20. I mean, that film changed my life, and I was on Twitter, and somebody was talking about how in Akron, and I was like, whoa, you missed the point, G. Like the movie's not about genetics,
right?
It's about how we, like you said, we look for these shortcut and easy fixes for society, and we think that we have more control over fate than we tend to. And I think that's where we're headed if we don't get our act together.
Are there ethical questions that we have mostly agreed on, and then sadly ones that we're maybe too late on, for the most part?
Yeah, for the most part. I mean, I think like there are very strict FDA regulations on, and so number one, there was like a ban on human embryos, like pretty much right away, which was good. And I think there are very, very strict kind of limitations about, I mean, there's some kind of legal baseball about gene editing versus gene modification, and some things involves adding things, and some things involves removing things. So one thing is we're sorting out kind of what the difference between that is, because people are less afraid of deleting things and adding things, even though it doesn't really matter. There's different rules. So a lot of this is still being sorted out. But my point is, the conversations are being had, and I think that's a good thing. I think, frankly, I think the situation with the CRISPR baby, which we'll call this child for lack of a better way to describe this individual, right?
Well, I mean, it's how they're going to be known for their entire life
at
this point, right? Because they're literally the first person in history we've ever.
Yep. No, they're going to be, scrutinized.
If it's true, aren't there? Isn't there didn't he not even provide evidence? Isn't it
No, there's no evidence. There's no, he didn't publish the results. It's kind of fascinating because this individual was trained with the best people in the world. So it's like people are confident that he did it.
Right.
It's just that nobody. There's been no. It hasn't been verified. It's very, very strange. So I think part of the issue is that the same standards that are held here and in the UK aren't held everywhere else, right?
Right.
So it's kind of universalizing, right, the ethics, I think, is the challenge. I think in the UK and in the US, I think the conversations have been pretty good about regulating human activity or outright banning it. And even in crops, I think there are regulations on transparency. That are good. I think what's not being, I think so I feel good about that. I think the problems that we still have are the greater problems that we discuss regarding kind of what are the things that we deem as disease, kind of like the autism example, and what are the ones that we don't. I think that's a conversation that needs to be had within the clinical community and the psychological community and in the educational community in the sense of autism. And I think those are ones that we're going to continue to have at a very, very detailed level, and we are having.
And they're so complicated, but I'm glad we are, because as much as we say the handicapped, again, the blind or the deaf community might say, wait a minute, don't wipe out this culture we've built. There might be, I'm sure there are people who go, yeah, I don't want to fucking be deaf. I'd rather live a more standardized full life. And of course, then you go further down the waterfall of, but that person's 14 and they're now legally allowed to make decisions for themselves, but their parents want them to not be deaf, or back and forth. But as long as it seems like we're pushing these conversations, even if it's so hard to establish standards all the way down the grain, the conversations are what are vital. So I actually I want to move into sort of what I feel like we do best, which is, so Brandon, as citizens who are either bystanders or could maybe quote unquote benefit from said science, what are questions you feel like now we should be asking of our representatives around this stuff?
Yeah, so I think there's, I call citizen scientists because we're all involved in this, even when we're not in the lab. I think you should ask, and we should ask. There's some scientific things we can ask, and then there are policy things that we can ask. So, from the scientific perspective, this is the thing that I study. Right, fundamentally, is how do we this concept of epistasis, which I talked about? It's how do we know that when we put a mutation in a given organism that it is doing the same thing in genetic background A versus genetic background B? And the flat question is, when you see CRISPR for a great brand of beer, this was brewed with GM, you don't have to get horrified by it. But a reasonable question is, well, what are the strains, right, of yeast that this CRISPR experiment were carried out in, right? How, or was it tested in one, verified one, and then kind of just thrown into a bunch of different strains without testing them, right? So you want to make sure that the thing that we're consuming, right, has specifically been tested, I think, across the different possible genetic backgrounds. So that's a practical question. It's and I think related to that is, right, one of the big other big things in modern genomics that kind of complicates the study of human genomes and who we are is the effect of the environment. Okay, so if you test kind of an effect, you have a mutation that's associated with really delicious beer, but only when it's, I don't know anything about brewing beer, but if you only do either of you, whatever. And I'm going to say something stupid, like if you brew it at room temperature or something like that. But but in certain places you can't get it to room temperature, and you heat it up, you get a completely different effect. That mutation that's associated with the yeast being able to do something is completely different in a different setting, or when you add a different ingredient or something of that nature, right? That could completely change the flavor of the beer. So my point is, and I use that kind of, trivial example for a reason, but because fundamentally the questions are the same for that as they are for the CRISPR baby. They are, all right, this mutation that we think is useful to humans or life or livestock for this reason, what environments did you test this mutation in? Did you test it across temperatures? Did you test it across a bunch of different, I don't know, like in bacteria, it's like pH of the solution matters quite a bit. Did you test it in a bunch of different culture conditions, whatever? So the point is, you want to make sure that anything being consumed or being offered to society via the CRISPR method, that it was tested in a lot of different, we can just call them contexts. Did we test this CRISPR thing across a bunch of different contexts? Because this tomato that grows beautifully in the lab in this setting, what happens when I grow it in another setting, right? That I think so. So I think that's a practical question that citizen scientists can ask of their science, and I think anybody in this industry should be able to answer that.
And it's important too, because it seems silly to ask those, to say like, but did you do it in did you try it in a room next door where it's 5 degrees warmer? And that might seem silly to some people, but it's like, this is shit we've known about, quote unquote. I mean, this is so fucking lazy. Regularly grown plants for thousands of years since agriculture, right? And we're trying to start from scratch with some of these things because if you're making germline edits to a plant, you're inherently changing the functions that have evolved into it for thousands and thousands of years. So we do have to ask those. And then to me, I would again just come back to when they say no or they say yes, it's why or why not? Why didn't you test that there? Was it because of speed? Was it because of money? Was it because you don't think it's necessary or relevant? Because that is actually, to me, gets to the heart of these things a little bit more.
Yep. And I think the good news and the bad news, but when I look at it, is that in terms of what to ask, there is a blueprint in place, and you'll see why I say good and bad news. There is a blueprint in place from the pharmaceutical industry, right? Right. And meaning a lot of the questions are actually rather similar, right? So when you have a kind of new drug on the market, right, the question is, who did you test this in?
Sure.
What was the structure of the population? And as you know, right, things are pulled off the shelf all the time because the range of people that it was tested in was narrow. And they didn't test it for long enough, and the long-term effects of this thing were negative, right? So my point is, there's a blueprint in place for how to ask that of kind of GM technology writ large. So that's that. I think
there's a blueprint, right? It's good that somewhere, again, for better or worse, like you said, the good and bad, there's an exhaustive list, which it can't be exhaustive enough of, did you test this everywhere? I think I remember my uncle was one of the first guys to have way back, one of the first guys to have LASIK. And at the time he was doing stupid white people shit. He was climbing a bunch of mountains. And I remember they were like, hey, could you go climb up to like 15,000 feet? Because we need to see if your eyeballs fucking explode.
Oh my God.
And he was like, well, we do have to find that out. So I might as well be that guy.
Right.
And it was in some fucking like climbing magazine or something. And like, it was just another box that they did need to check. Even as much as it's like a niche thing, this niche thing could apply to a lot of fucking people.
I don't get how these things are not happening. And yet all these procedures or drugs or whatever go out anyway. And then have to get pulled because then you find out, oh, fuck.
Look, I mean, I might act like I'm well-rounded and well-read, but I'm a geneticist. I'm an evolutionary. I study so I'm on that side ultimately.
Right.
Sure.
So my point is, but I say that for a particular reason. The thing keeping my lights on, and the reason why I got good wine in my cupboard, is because I can tell you that the effects of mutations change in different environments. That's the thing that I'm studying right now. So my point is, nobody should tell you that's a stupid question.
Right.
Because it's not a stupid question. I got data to show that, right? And I think a lot of people have data to show that. So they lying. Like I hate to snitch on my people, but like, nah, like you should be able to test these things across ranges. That's a reasonable and fair question to ask of the science.
Well, and I think that's probably some of the fear that people have with like GMO foods and stuff like this, and why we're so quickly to say like, we need regulation, we need a label on it. And by the way, a lot of times, most of the time, some regulation is great. But I think it's easy for people to go like, Monsanto didn't test this, they don't know what this does, this and this. And by the way, some of the times they might not have fucking done that.
Right.
But
yeah. I get that. I mean, the thing is, and I'm not anti-GM crop at all. Like, I think this thing has number one, I think a lot of the fear of genetically modified crops in particular is based on an old antiquated idea of you call it the naturalist fallacy. Things that are in nature are better, right? And that ain't true, right? That ain't true at all. Nature comes up with all kind of screwed up, bad, awful things. And so it's not bad simply because we engineered it. And I think that's why people hate it. But at the same time, I do empathize, like you just outlined, with the notion that, we should be able to answer the question of whether or not something was tested across environments.
Now, I'm going to ask you to use your wildest imagination here. Imagine, Brandon, that I am a young scientist, and I actually want to get into this work. Where do I start? What do I do, and how do I have the most impact?
Great question. And so, what stage are you, if I might ask? How old are you?
Let's say high school.
Yeah.
Right? These young people that are out there are going to change the fucking world. I mean, I'm basically anybody over 45 we're done with, right? They've had their chance. They've ruined the world.
Pretty much.
Right?
Yeah. So great question. Yeah, great question. It's a great question because, educating the public is a big part of who I am as an academic. And I think about this carefully. So, and this is also interesting because this has changed during my academic life. So what I would say is pay particular close attention in math class.
Yeah.
And because biology as a whole has gotten a lot more quantitative in the last, 15 years or so. And I think this is people who study math and computer science are really the ones in many ways who are kind of running these fields, even fields like CRISPR in many ways. I mean, CRISPR was a very, very laboratory and empirical, discovery. But I think like the field of like bioinformatics and things of that nature, they're the ones, right, who or maybe even we're the ones. I'm kind of that ilk.
You're a computational guy, right?
I'm a computational guy, so I think I pivoted at the right point. I mean, so to speak. So number one, I would get really, really adept quantitatively so that you understand things like statistics, you understand computer science, you understand that. In addition to that, right, you should pay close attention in English class. The recommendation is, kind of lame in the sense of, listen, I was a lousy high school student, so I don't care. I'm not saying get A's in all your classes, but what I will say is make sure you're reading broadly, right? And understand kind of what U.S. history was and world history was, so that when you enter these conversations, you can bring something else to it, right? And I think this is really the problem, is that this underappreciation for how arbitrary things about the way we've structured society, we conflate that with solutions that could be provided by things like CRISPR. So that's what I would tell a young person.
I love that. And it is incredible. And I imagine the computational side is only going to just keep exploding over the next 5, 10, 20 years. Look at what groups like, the Flatiron Group, like Jim Simons is doing in New York and stuff like that. It's just, it's wild and hopefully for the better. But yeah, as a liberal arts major, I couldn't agree more. And again, we come back to the Silicon Valley thing. We have to have people who not just ask these questions, but know how to ask the right questions and say, stop, we should think about this. Why are we doing this? Why not? And if you can bring both of those things to the fold, that'll be even more impressive, and we will be thankful for you.
This is so great. I wish that I gave a shit when I was in high school.
Oh, I was worse.
Would have been just incredible.
A monster.
Brandon, we've only had you for almost an hour here. Thank you so much for being here, man. We're gonna, wrap it up, ask some more questions and stuff, but we really appreciate it. All right. This is what we call the lightning round, Brandon.
Yep.
All right.
We got some questions for you. Get ready.
Yeah. Hey, so Brandon, when was the first time in your life when you realized you had the power of change or the power to do something meaningful?
It was probably my freshman year of college, and not unironically, the same year I saw Gattaca. So I think that was the year when, number one, that's the first time I started really doing well in school. I mean, I knew school was easy for me through high school, but I think that's kind of, I had an identity kind of thing, an awakening, and I learned that, wow, I'm actually really good at this stuff, and people appreciate me for it, and wow, these concepts connect to real problems in the world. And I think it's funny. I think I think Time Magazine had awarded a Man of the Year to an AIDS researcher, and I think that was another kind of moment. So I think it was in that window of time.
Yeah, that makes sense. It's amazing when and how things impact you. Wow. Who is someone in your life that's positively impacted your work in the past 6 months?
Oh boy. I mean, I'm a collaborator supreme. I think there's a scholar. Actually, I believe he was on the show. So, Dr. Sam Scarpino.
Oh yeah.
Yeah, Dr. Scarpino has been really, really great for me. I think our work overlaps in some ways, and I think he's kind of taught me kind of new ways to think about some of the problems that I work on, and hopefully I've taught him a few things. But I think kind of having cross-pollination with somebody relatively nearby, whose work I respect and admire, I think has been really, really important for me to being able to grow as a scientist.
I love that. And even if you're working on slightly different things, it is amazing what can come from that sort of relative interdisciplinary approach, or at least environment, I feel like history is littered with those type of interactions. So, what do you do when you feel overwhelmed by everything? Specifically, things have been a little chaotic.
So you mean all the time?
Yeah, right. What's your day to day?
I love consuming. I mean, this is gonna sound lame, but it's true. I love consuming creative and dope ideas in different realms. Like I love music, I love hip hop, I love film, and I like to see kind of human creativity on display, which is why I have such a deep connection to sci-fi. So all the stuff you're talking about with Star Wars, and I got very strong opinions on all that. I mean, I agree with you, but with everything, But my point is, I think I love the human capacity to create, and so whenever somebody's doing something interesting and cool, even if it's not something that I know about or I dig necessarily, I want to at least experience it. So that kind of keeps me hopeful about where we are as a species.
I love it, man. Anything you've really dug lately?
Yeah, I was just gonna ask.
Yeah, I mean, you mean just in general, like
in general,
just general things. Yeah, so I mean, I think I've been impressed with I saw a bunch of good films recently. I saw a bunch of good films. So I've been enjoying films. So so recently I just saw, did you see the new Spider-Man movie?
Oh yeah.
Did you guys see that?
So sick.
Is it so great? I really want to see it.
Oh my gosh. It's beautiful. And I think, so that's a good example. I'm glad I didn't think about this. So that's a good example. So that film had such a big impact on me that it got me thinking so apparently like the animator community is way bigger and richer and more wonderful. And I don't draw shit, man. I don't do any of that. But like there's this whole wonderful, diverse world of like animators, and they got their own culture, and they like, and so I'm not on social media all that much, but like, I've started following a few of them, and just every day they post new little interesting things, and I'm like, wow, like here's this thing that I've kind of, I've seen all these Pixar films and I like them. They've obviously been tremendously successful in these other animated films, but I've just taken it for granted.
Sure.
It's a type of genius. I was like, well, I had no idea. So frankly, I'm looking for ways to kind of work that into my. There's this one artist who drew his drawing sketches of my lab members for me, and I'm trying to work this into kind of what I do as a scientist somehow. I don't know yet, but that's an example of like me being inspired by something and me following up on it and me trying to kind of work it into the things that I do.
Yeah, there's a hell of a lot to take away from that movie. From the art to the sci-fi side of it to the superhero stuff. It's
don't spoil anything, all right?
Nah, man, go see it right after this. Like, go.
I already Googled Showtime. So Brandon, how do you consume the news?
I sit down and I read the New York Times like a lot of people in my demographic. They've had some issues recently, but I think everybody has, and I try to, I haven't been great about consuming 10 and 15 different news sources.
Yeah,
I have friends who like some of the news is it's just so it affects me so deeply and so personally that I can't bring myself. I'm not even gonna say it. I can't even listen. There's some stations I just can't turn on because it's gonna ruin my day.
Right.
You know, so I think it's a balance between. I think the argument for consuming that poisonous stuff is that it's important to know what the world really thinks, right?
Of course.
Which I get, but I think not if it ruins my day and it prevents me from being able to do the things that I have to do. So in some ways, I'm still sorting that out. I think I try to stick to kind of publications and institutions that have built my trust over the years, and I try to remain critical of them as well.
Nice.
I love that, man.
All right, if you could Amazon Prime one book to Donald Trump, what would it be?
Oh shit.
We have had
this is a
full line of
a
wide variety of shit.
What a range. We're going to include it in our Amazon book club.
Yeah. I mean, well, so it's tricky, right? Because it's like, is he going to read it?
We're assuming that he will read it or that somebody will read it to him.
Yeah.
All right. Fair enough. Fair enough. I think there's a great book about, to give a perspective that, about how, I try to read broadly. I'm interested in mass incarceration the way a lot of people are these days. It's one of the big kind of social justice issues of our time. And there's a great book, from the war on poverty, the war on crime, the makings of mass incarceration in America. And I think it's by Elizabeth Hinton. And I think that book really, I think what really struck me about that book is that it kind of outlined specifically like the very practical political decisions that were made that kind of led and created the policies, the modern mass incarceration. So it kind of examines a bunch of presidential, going back to Johnson and Nixon, and it kind of it's humbling and kind of like wow to kind of read how these decisions that a handful of people made really crafted, our crime control policies today. I think it's one of those things where, as a kid, I was a conspiracy theorist the way everybody is.
Of course.
I was a conspiracy theorist the way anybody is, but it's one of those things where, wow, you don't really need far out conspiracy theories when you have books like that just kind of articulate it in a very intelligent. So from the war on poverty to the war on crime.
That's a good.
I would say
that one in combo with the new Jim Crow by Michelle Alexander.
Those are the two. I mean, those are the defining.
They're incredible.
Those are the defining ones. Mm-hmm.
Yeah, I love it, man. I love it. That's a good one. So Brandon, last question. If you want to use, obviously you talk to incredible students every day, but if you're going to use this podcast to speak to a little truth to power, anything, last things you want to say, get out there in the world before we let you go?
Oh, wow. Truth to power.
Anything.
Well, I mean, I think, how would I say this? I think just, and I'll speak this is from my scientist hat, so to speak.
Mm-hmm.
That is that we cannot, we're a species just like everybody else, or, unlike everybody else in some ways, but like everybody else in the sense of we're not there's nothing guaranteeing our existence. And so I think we should kind of treat our time on this planet, right, as a very tenuous and sensitive thing. And so, right, I think, act like we belong here, but act like we're not guaranteed to be here. And I think that's not like a sad thought.
No.
That should be an empowering thought. It should be like, the things that I do actually matter. And this is why, like, I think, and I think, studying, right, reading about, from my culture, right, the African American experience, is, there's a reason I'm a big fan of things like hip hop, is because it was and jazz and these kind of cultural American inventions. It's because it was, it's people who wanted to say something and found a way to say it. And I think, always kind of, always be willing to do that, no matter how kind of crazy or, I think the teenagers who invented hip hop had no idea they were going to create what they created, and look what they created, and hasn't always been good, but nothing ever is. The point is, be creative and leave the world with some cool new ideas, because you never know who's reading them. And you never know what they're going to do. So that
love
was
it,
a
man.
mouthful, but you know.
No, it's good, man. I love it, man. I love it.
It goes back to why you said you were vital, because you have the courage to lead
And do new shit.
right.
Yeah.
Pretty
Hope
dope.
so.
Hey, so we obviously mentioned your pretty dope Twitter handle, Big Data Kane, but where can everybody follow you online besides that?
Is that the place to be?
Yeah, you can find the rest of my stuff there. I'm also on Instagram, which I don't use much yet, but I will start. But yeah, Twitter, big_data_Kane, Kane, as in, as in, and yeah, I think I have a website there. I have a Medium page, right? Medium.com
Sure.
/OG Plexus. And that's OG Plexus is, OG is the first two letters of my last name. And Plexus is, I call my research group a plexus. And a plexus is kind of an interconnected network of things. And so, I don't run a lab, I run a plexus. That's how I think about it. So you can also find it there, which you can find on the Twitter page.
All right. We will put all of that and everything else we mentioned today in the show notes. Brandon, man, we cannot thank you enough for your time today and all that you're doing out there, man. As a scientist and as a educator and communicator, all those things are equally vitally important in our eyes. So thank you, man.
Thank you for what you're doing. I love what you're doing. I think this channel what you're doing is an example of what I mean, having the courage and to kind of ask the important questions and the diversity of people that you bring on here. I mean, this is how we make change happen. So, congratulations for the two of you. And really, thank you for giving me this opportunity.
For sure, man.
Oh,
Least we could do. All right,
Thank
Brandon,
you.
we'll talk to you soon, my man. Thank you.
All right. Take care, Jim.
Take it easy.
Thanks to our incredible guest today, and thanks to all of you for tuning in. We hope this episode has made your commute or awesome workout or dishwashing or fucking dog walking late at night that much more pleasant. As a reminder, please subscribe to our free email newsletter at importantnotimportant.com. It is all the news most vital to our survival as a species.
And you can follow us all over the internet. You can find us on Twitter at importantnotimp.
Just
so weird. Also on Facebook and Instagram at Important Not Important. Pinterest and Tumblr, the same thing. So check us out, follow us, share us, like us. You know the deal. And please subscribe to our show wherever you listen to things like this. And if you're really fucking awesome, rate us on Apple Podcasts. Keep the lights on. Thanks.
please.
And you can find the show notes from today right in your little podcast player and at our website, importantnotimportant.com.
Thanks to the very awesome Tim Blaine for our jammin' music, to all of you for listening, and finally, most importantly, to our moms for making us. Have a great day.
Thanks, guys.